Well, thank you very much for this invitation, and I think it's great to be here. And I will talk about, I have looked at milk and beef. I have been a researcher for around 15, 20 years, and before that I was some year in the extension service, very much for dairy farmers, so I think it's great to be here. Now, we have talked about efficiency in the agriculture. And I just have an example here. When we talk about efficiency, we have very much talked about increasing the output per hectare or per animal. And this is the example from Sweden, from the dairy cows, where we can see how much milk each dairy cow has delivered for the dairy from 1960 until now. And it's an increase about 1,000 kilo milk per dairy cow and 10-year period. I mean, it's a great, and I think it's very typical for Western Europe. However, future, and I think we should put now here, is we talk about sustainable intensification. If you look in research and food now, sustainable intensification is very, very important, and you see it everywhere. And actually what we need, we have to produce more on the same or even less land, and we have to reduce the environmental impact. And you have heard this from speakers before. So I will speak around this, and I will use 3 areas: the nitrogen, soy, meal, and about the intensifying of milk and beef. And the reasons I picked these 3 areas is because I have done research in them, so I feel in my comfort zone now. Let's start about nitrogen. Now, nitrogen is so important for agriculture. I would say it's the most important nutrients. And if we look back around 100 years ago, there was actually big questions. How are we going to handle the nitrogen question? We introduced legumes, especially clover, here in Northern Europe in the 1600 and 1700 century. And when the Industrial Revolution came, I think that people underestimate the importance of clover for producing more and more output so people in the cities could have food. So the clover was extremely important. But when we turned into the 20th century, there was a question: how are we going to deal with this? And I'm sure you know about this Haber-Bosch technology to produce mineral fertilizer with the help of fossil fuels. And you take nitrogen from the air and you produce ammonia, and then you can produce fertilizers. Now, this is actually was used mostly for producing guns first, because it's a good ammunition. But after World War II, we have had this very, very large production of synthetic fertilizers. And I must say that this 100 years, it's an extremely big change in how humans interfere the global nitrogen cycle. It's extremely big change. And the prognosis here, if you look at this one, you can see the prognosis for, where have we, here. Here you can see the fertilizer production going up very, very strongly. And the green one here is the N from legumes. But if you look here at the projected input of more nitrogen in the system, you can see that the prognosis is a very strong growth. And that is, of course, for feeding more people. Well, if nitrogen was a problem around 1900, because how do you get it for our crops? Now it has become an environmental problem. And we have some major emissions from agriculture. If we have this input of nitrogen through industrial, like the Haber-Bosch methodology, and biological via our legumes, we get into our crops. And as we have heard, much of the crops actually go to the animals. And they go to the animals, this extra loop, and we have a lot of nitrogen ending up in the manure. And you can see here that we have emissions of leaching, nitrate, ammonia, which are bad for eutrophication, for acidification. And when the soil turns over nitrogen, we have emissions of this greenhouse gas, nitrous oxide. So that's a complex of very, very important emissions here. And it's quite clear that this extra loop through animals is not the best, actually, for the nitrogen cycle. And this is an example of how it looks today. And if we had done this picture 100 years ago, this would have been extremely different. And what it shows here, that is how much more nitrogen is transported in big rivers, and it's a percentage of the most darkest areas. It's about a 500% increase. And you can see typically here that it's very much associated where we have intensive agriculture and also intensive lot of people living, because the nitrogen ends up in the manure from people and we have to take care of that. So this problem here, we have pollution of groundwater, we have pollution of our coastal waters, eutrophication, and loss of biodiversity, impact on fishes. This is actually one of the major environmental problems we have. If we look at the budget today for European agriculture on the land and look how the input looks, we can see here that the input here is about 10-11 million tons. This is for the whole European agriculture of this synthetic fertilizer. And then actually almost as much come from manure. So the manure, the nitrogen in the manure is almost as big. Very little now is from biological fixation. We have actually changed this N input over the 100 years in Europe very, very much. And today we have so little legumes, and we have some atmospheric deposition. And the output in products, what we take away from our field, that's about 10-11%, and that means that we have not more than 40 or 50% utilization overall for the nitrogen. Now, what can you do to increase this? And I'm sure you are farmers here, and I'm sure that you are well aware of some of what the extension service and the researchers say, like lowering the proteins in the feed so you don't give too much nitrogen and not too much protein in the feed, to avoid over-fertilization, especially when you have both manure and synthetic fertilizers, and you can have new application. However, I'm kind of, I wouldn't say pessimistic, but I'm kind of realistic how much the separate farmer actually can do when to handling this problem. And I think this picture is some kind of a, where is the problem? And this is from the FAO, and this represents a concentration of livestock. This is pigs. And you can see the areas where you have dark red colors. That's where we have the pigs of the world. And it's a very big concentration actually in 3 regions, and that is in China and East Asia, it's in Northwest Europe, and in some states of United States. Which means that we have to put in grain and soy in these areas, and we got a lot of manure. More than 50% of the nitrogen ends up in the manure, and we have this concentration. Now, how are we going, because this is not a long-term sustainable thing to do, how are we going to handle this? And we can think about more technology to handle this manure. You can separate manure, you can break it down, as we heard here from Wageningen. You could, you could try to do that. But the technology, I live close to Denmark, and Denmark are very good in developing, but it still costs money, this. Or we could think, is this the right way to have? Should we have a more integration of crops and livestock? So we have a more balance between land and between the animals. I don't have the answer of this today, but I think it's very important that we are open to both options here. Because this problem with concentration of manure, because we concentrate livestock, is a very, very big environmental issue of the livestock farming. And when we have developed the livestock and looked for this efficiency, this has been overlooked, and I think that we would need some type of measure for this, and I do think that we need a nitrogen footprint. So when we produce milk or pig meat or chicken meat or vegetables, we should have a nitrogen footprint to give information to the farmer, to the overall, but also to the consumer, how to choose food with less environmental impact from nitrogen. I'm going further on to soy here. And soy meal is very interesting if you are doing research or you work in livestock, because soy is the primary protein in the world here for animals. And I want to point out I think, a trend that I don't think has been sustainable intensification in how we use soy. This is my opinion. I will see if you think the same. This is a picture taken from a soybean field in Goiás, where I traveled in Brazil 2 years ago to look at actually pesticide use. And this is, again, a Swedish example. And I have looked at how much soy meal do we use to produce animal products in Sweden and what has happened during 15 years. And here you can see that we have an increase for over 15 years, which is quite high, especially in eggs and chicken meat. And also for that in pork. So we need more soy meal per ton of product. And this development is, these 15 years from 1990 to 2005, there has happened a lot of things in livestock. The globalization has taken place. We transport feed much more. And one thing that happened was the BSE crisis in Europe, where we had this BSE, and it refused to use meat meal. So in 1990, we used meat meal, and we also used fish meal to feed chickens and poultry. However, now we have got this aquaculture, growing fishes, and they compete about the fish meal. So the livestock have to find other protein sources. So we have actually increased. And this is a Swedish example, but it's typical for the whole world. It's a growing dependence of soy. And you can also see in this indicator, this is data from the FAO. And what this picture shows, so first look at cereal production and harvested area. We can see that in relative numbers, if we compare with 1960, we can see that the area for cereals has increased all over the world by a few percent. And production has increased by a factor of 2.8. So cereal is, we have been able to, the growing demand has been able to use by growing yields, basically. The situation for soybean, which is so central for the world's livestock production, is very different. Here we have the harvested area. This has increased by factor 3, and the production has increased by factor 8. So that tells us that the demand for soybeans have been relatively much larger, and it has not been enough with increasing yields. We have to have, expanding areas. And this means land transformations. And this is also pictures from my journey. And here we are seeing in the Cerrado, which is the savanna. This is not the rainforest area, where we travel in this type of Cerrado vegetation. It's a bush vegetation with small trees, or larger trees for that case, and with a very high biodiversity, actually. And if you travel about 20 minutes, you came into this type of areas where you actually have monocultures of soybeans. What has happened here due to this land transformation, it has taken place over around 15-20 years, is that you have lost biodiversity, and this transformation has meant greenhouse gas emissions, because this vegetation holds a lot of carbon also in the soils. And it has also meant a very strong use of pesticides. And I just try to explain this because I went there to study the pesticide use. And just to look here at the cycle, how they grow soy, they plant it in September, October, November, and start to harvest over here. And there is an intense use of herbicides and insecticides, and also actually desiccation to get the crops ready for time. And now, due to the growing world commodity prices, they come with a double crop. So after the soy, it's more and more common that they plant corn, and then they harvest the corn over here, and then they start a new cycle. And this takes place year after year after year, and you must think 20 years ago there was this pristine vegetation. So the eco effect here on the old nature and also human is very big. And the problem is here that if you want to know where does all these pesticides go, there are very few programs of monitoring these pesticide residues. This is a very, very cropping system that is very much dependent on pesticides. And my conclusion here is that this increased soil dependence has been negative for the effects of pesticides, biodiversity and emissions, but we don't know how much because we don't have good measures, good indicators. So again, we need better measures to follow this up. And for example, we need some type of pesticide footprint, and especially if we look at this dependence in soy, where some of these products used are actually banned in Europe and not used because of health for the workers in Europe, but they are used in South America a lot. Now going to the end here, and that is about milk and beef, and if it's correct to do all this intensifying of milk yields. I think there is a myth that it's always better to have more and more milk out from one cow. And that is because we have to look at the integration at beef. And I will try to explain what I mean here. And there is also this myth that if we increase the milk yield, we will have a lower carbon footprint of milk. That is less greenhouse gas emissions. Now, I've talked about that we need nitrogen footprints, pesticide footprints, but what this climate change discussion has given us, we have quite good methods to calculate and estimate carbon footprint for products, and I'm sure you heard a lot about this. And this is basically about looking at the life cycle greenhouse gases. For cows, it's methane. This is this nitrous oxide, mostly from manure and fertilizers. And we have CO2 from fossils and also from land use. And we have good tools to do this now, and there are a lot of work being done here. And my PhD, Anna Flysjö, and I, we did a comparison of Swedish and New Zealand milk for just some 2 years ago, trying to calculate it in a very, very similar way, so the methodology was the same. And just look at the thing here, it's about double as high production per cow. This is typical for Western Europe, but also double as high feed intake. And you can see that the New Zealand here is based on roughage and pasture, while in Sweden and also in Netherlands we have much more concentrate feeds. Now if we look at the carbon footprint between these two, this is the same carbon footprint, but we have tested different ways of calculating this nitrous oxide. You can see that the differences between New Zealand and Swedish milk is very, very small. So despite that you have half as much production per cow in New Zealand, you have small differences. And the bars here are showing the uncertainties when you calculate these nitrous emissions. And that is what that tells us, is that we have to have quite large difference to say that there is a difference. So there are small differences despite you have this much lower production per cow. And I think that is a way of saying that the New Zealand pasture-based system I think it's extremely interesting what they have done down there. Not going for the maximum yield per cow, but you use the grass-based and the climate of the year and the season of the climate. It's a very interesting system, and I think what we heard from the last speaker here about exporting that type of knowledge is very good. Now we just look at the milk and beef, this integration. Now we produce milk with this system, and we get emissions of greenhouse gas and we get resources. But we do not only get milk, we also get beef. And beef that is from the culled cows, but it's also from these surplus calves, which are raised into beef cattle. And if you look at the whole global system today, it's actually more than half of the global beef that comes from the dairy sector. So they are extremely interlinked and they couple each other very much. We did this thing where we looked at dairy farms in Sweden where we had done carbon footprinting. And we looked at 23 farms and they had milk yields per cow from 6 tons to 12 tons. And then here we have the carbon footprint. And we calculated for each farm. And if you only look at the dairy system here, this is only the dairy system, you can see there is a trend towards a falling carbon footprint when you have a higher yielding cow. But then we have to think about the products of beef. So we added, because per every ton of milk we will have some beef production and we have some surplus calf. So we added the rearing of this little calf to make it to a beef. And then we had a reference system for the 6-ton milk per cow, which was 1 kilo milk and 44 grams of beef. But this farm over here, which have 12 tons, they had much less beef production. So if we want the system to produce the same amount of beef, then we had to look at what is the alternative way of producing beef. Well, that's a suckler cow system, which is somewhere else. And to get the same amount out from every farm, that is 1 kilo of meat and 44 grams of beef, you could say that this farm here needs someone else to produce that beef, while this farm, having 6 tons per cow, produce it by himself. If you look at them this way, there is very, very little difference in different milk yields per cow. And we have also, this interaction has just recently been looked at in research, and this is a study coming from University of Munich, where they have looked at German cows. And as I understand, they have in south of Germany a lot of dual purposes cow, Fleckvi cow, which not produce so much milk, but they have a good meat production. And then in North Germany, there are a lot of this Holstein cow with a high production. And here we can say that if we want 6,000 kilo milk, we only use 0.6 cows to produce with these high-yielding cows. But in turn, we have much less beef production from this system than from that system. And to compensate for this, we have to have suckler cows. And what you can say that here, you can see you have this trend towards lower carbon footprint with higher milk production, but the beef that is produced will be more expensive in production because we have to have more suckler cows to compensate. So this is only true if there is a constant beef production, beef consumption or even increasing. However, if people stopped eating beef, then we should go for as high yielding cows as possible in the future. But if people want to eat beef, I think it's very questionable to go for more and more and more high-yielding cows and then replacing this lost beef by pure cow suckler system, for example, like the ones in Brazil now taking large land areas. And this is a good example how we need to look all over the system in the future and not so much specialized. Okay, I'm coming to my end here, and I think what I want you to remember from my little lecture here is that this sustainable intensification, what does it mean actually? Well, we must increase the yields per unit of inputs. So we must be more efficient per kilo of nitrogen, energy, etc. And when we say increasing yields here for milk, it should be maybe milk and beef together. And we also must be much more increasing per unit of undesirable outputs. And we have started to calculate greenhouse gas emissions, we have carbon footprinting methods, but we need other measures. We need nitrogen footprints, biodiversity footprints, pesticide footprints, because we do not have enough information about the implications of what's happening now. And everything is going very fast. I think this soybean example for over 15 years is so good example of this. And I think that this, how is milk and beef interlinked? I think this is a question that is overseen in research. And I think that we have to look at much more integrated. And the potentials here by having this dual purpose more is that maybe we have less medicines, we can use land that is not so good, we can use less soy and grain, we can use more grace-based diets. So I think this is a very interesting system that we should look much more into. Thank you so much.